Okay, students, we're going to talk about how to do some binomial functions using your TI-83 plus or your 84 plus. You can do binomial distributions with these calculators, but sometimes there's a trick to it. They only work one way, so to speak, unlike the 89 titaniums. We're going to be using the distribution key. It is the second key and the vars key. So you see in orange or perhaps blue or pink, whatever your second key color is. Mine is kind of orangey yellow. You'll see it that it says distr, meaning distribution. Okay, so of course let's turn our calculator on. There's two choices with the binomial. We got to scroll down and find it though. So let's scroll down. Okay, here we go. We've got option 0, which is binomial PDF. That's if you want to find a single probability, and we'll be using that in our example. And then binomial CDF, that's if you want to find multiple examples. The thing is, though, with the CDF function, it only works less than or equal to. Only works less than or equal to. So if you have a greater than statement or something that's not in this format, you've got to manipulate it to be in that format, which we can definitely do. Let's just work on an example, and let's say that n is 10 and p, the probability of success, is 0.7. Okay, this is like the example that we did in the notes. So let's assume that we want to find the probability equals 8. Probability that x equals 8. 8 good items, right? So we're going to hit binomial PDF because we're only wanting to find a single probability, so I'll hit that. We have to input it in the forms n, so n is 10, and then comma, p, the p value, probability of success, 0.70 or just 0.7, comma, and then the x value that you want, which in our case is 8, and then you have to close your parenthesis and hit enter, and it brings it up as being 0.2335. Okay? And if we do it on the table, you just get 0.233, but if you do it in the calculator, use your formula. When your calculator is set to only 4 decimals, you're going to get 0.2335, and that's fine. Now let's do the next one here. This one is x is strictly less than 4. So we want 0, 1, 2, and 3, right? That's being strictly less than 4. So let's rewrite this in a less than or equal to statement, less than or equal to 3. Okay, now that I've rewritten that, I can use the binomial CDF function, because the CDF function only works in less than or equal to statements. So let's go second, the distribution function. Let's bring up the binomial CDF. Let's input our n, comma, our p, comma, and now we're going to input the topmost value here, which is 3. Okay? And we get 0.0106. So if you have a less than statement, you have to turn it into a strictly less than or equal to for this calculator, only for this calculator. Now let's talk about what happens when you have a greater than or equal to statement. Well, you've got to change it into a less than statement. So if you want greater than or equal to 6, you want 1 minus x less than or equal to 5, right? By the complement rule. So that's by the rule of the complement. I know from other examples we're supposed to get 8490 approximately. This was from the table. And if you followed the example in class, then that's what we got when we had these conditions. So let's see if we can get 1 minus that when we do the trick. So second, distribution, go down, and again I explained the tricks in class and in the notes and everything, so you should have seen that already. This is just how to input and talk to your calculator. You input in, which is 10, P, which is probability of success, 0.7, and then let's input 5, and it gives us 0.1503, and then if we say 1 minus 0.1503, we get a little bit different value because it's using its calculator formula, 8497. So this is a more accurate one. This one was from using the table. Remember, the table is going to have some definite rounding error. But so the point is, anytime you choose to use your 83, 84 pluses for the binomial, remember its CDF function only works less than or equal to. And that's really important, okay? So play around with it, you know, compare it to the table results. You're going to find a little bit of rounding difference because the tables are just full of rounding error. But remember, they were our tool that we had before the days of calculators. So play around with it and let me know if you have any questions.